Hello and welcome to my channel. In this video, I'll be showing you how to use compute shaders to create a falling sand simulation like the one you're seeing on screen right now. To begin, I'm going to go into Unity Hub, create a new project. I will choose the latest Unity editor version that I have, which is 6000.2.13 F1. I will choose the Universal 2D Core option for my project. I will choose a place to save my project, and I will call this Falling Sand Tutorial. Then I will go ahead and hit Create Project. So one of the first things I'm going to do is select my main camera. I will go to the environment section and I'm just going to make the background completely black. Then I want to create a canvas and I'm going to say this is world space, and I will select the camera in my scene as the event camera. Then underneath the canvas, I'm going to right click, go to UI and create an image. And this is going to be our background image. And this will be the image that we use our compute shader on to project a render texture. And it's also going to be the thing we interact with. So down here in assets, I'm going to go ahead and right click, create a new folder, and I will create a folder called scripts, as well as a folder called shaders. And I will go ahead and create a script in the scripts folder, and I'm going to call it Falling Sand Controller. And I will go ahead and attach that script directly to my image. Then I'm going to double click on my script to open it in Visual Studio. I'll zoom in a little bit so we can see. And I'm going to add a couple libraries here at the top. So I'm also going to add using Unity engine.ui so we can reference UI elements, as well as using Unity engine.input system. That way we can detect like when a mouse is clicked and stuff like that. For right now, I'll go ahead and delete the default values. And I'm going to start adding stuff that I know we'll need. So first off, I will add a public float called range, and I'll set this equal to like 10. And this is going to be representative of the range of the circle that we draw on the image for when we're actually drawing the sand on it. The next reference I know we'll need is a compute shader reference for our falling sand shader, and we will also need a reference to a render texture, and I'm going to call this falling sand RT. We will also need a reference to our image, so I'm going to create a private image and I'll just call this image UI. And in our awake function, I am going to plan to call a couple functions. So first thing we got to do is create a render texture. Next thing we need to do is set the material, and that's going to be setting the material to the image UI. And the third thing is we'll need to initialize our image. So just kind of wipe it clean and set it to black. So we will need to initialize render texture. So the first thing we'll do here is create a render texture. So I want to do that in my own function. So I'll go down here and create a function called create render texture. And I want to create it for our falling sand RT that we defined up here as our render texture. So I'll say falling sand RT equals new render texture, and I want it to be screen.width by screen.height, and I'll also just have it be 24-bit depth. I want to enable random write to it so then we can draw on the render texture. The next thing I want to do is set the filter mode to point filtering so that it is not blurry. So I will set that to filter mode dot point. And then the last thing we need to do is create it. So fallingSandRT.create. That's good. Then we will need to call it in our awake function. So I will say create render texture up here. Next thing we'll want to do is assign that texture to a material for our image UI. So I'm going to go ahead and create a set material texture function, and we'll need the image UI. So I'll say get component, since this script will be running on the same game object that has our image component. So I'm just going to say get component image, and then I'll say image UI dot material dot set texture, and I'm just going to set it to the property main text, and I want that to be our falling sand RT, falling sand render texture. So then I will reference this function here. Now, of course, we still have to make this material with this property, but when we do, we'll have to make sure the property's name is main text and that the reference to it is underscore main text, and it works how we want. So we'll just have to keep that in mind for later steps. And then initializing the render texture is going to be done in a function called dispatch. So I'm going to create that function, and what this function does is it takes in a kernel, which is going to essentially be the name of a function inside of our compute shader, and it's going to set all of the values needed for the compute shader and run the function that it is sent. So I'm going to pass it a string called kernel, and for right now I'm just going to say integer kernel handle equals falling sand shader dot find kernel of kernel, and then it'll depend what values we have to set, but ultimately in the end we're going to want to do falling sand shader dot dispatch kernel handle comma falling sand RT dot width divided by 8 comma falling sand RT dot height divided by 8. Oh, and then comma 1. All right. So this function is going to be something that we update as we go and as we define our compute shader, as well as the properties needed for it. But for now, I'll just do dispatch, and I'm going to define my kernels up here. So I will want a private string called initialize kernel, and it's just going to be called initialize. And for this dispatch function, I'm going to pass the initialize kernel. So we will have to define a function in our compute shader called initialize, and we want that to set the image to black to just kind of wipe it clean before we start drawing on it in case there's any remnants of a past image. And yeah, so let's move on to creating that compute shader. So let's go back into Unity. I'll go back into shaders folder, and I'm going to right click, go to create shader, compute shader, and I just named it falling sand compute shader. Let's go ahead and open that. And this is the default compute shader code that they add into any compute shader that you create through Unity. So up here, these pragma kernels are going to be our functions, and down here are also our functions. And right above our functions, you'll see we define the number of threads that we want to use. So it's 881. I'm not exactly sure what this breaks out to, like what is exactly meant here by this, but I think it's how many threads are able to be ran in parallel. But I don't know why there's 3 fields exactly. But those numbers match up to our dispatch call here for the width being divided by 8 for the width and the height. And then the last field is 1 because this last field is also 1. So we need to create our initialize function. So let's go ahead. I'm just going to copy this so I know I have it completely correct. I'm going to replace the kernel up here with that, name of the function down here with that, and I just want to set this to zeros for each of these. Delete this comment here. And as you can see, they already came up with a parameter for us, and it is a read write texture 2D, so called result. So that's going to be our render texture that we're passing in. And inside here, where we say result of id.xy, that's just going to be the pixel at the specific x and y coordinate. And then this float 4 is a color value, so it's going to go red, green, blue, and then alpha here at the end. And by setting all these to 0 for every xy coordinate, we're just going to make the image completely black on initialize. So let's go back to our compute shader. So we know we need a render texture. And just to keep consistency, I don't want to call it result, so I'm just going to change it to sand RT. I'll replace this one here too. Save that, and then we need to reference it in our compute shader, or not in our compute shader. We need to reference the compute shader variable inside of our falling sand controller script. So I am going to make a property string to keep track of that. So I'm going to go here and do private string sand RT property equals sand RT. And then when we go down to our dispatch call, we're going to need to define that for the shader. So we're going to do falling sand shader dot set texture, and we're going to do kernel handle, comma, sand RT property, comma, falling sand RT. So we're telling it which kernel we're doing. So that's what function. So here's what function we're sending this for. Here is what property we want to set for the texture, and here is the texture we want to set. It's going to be our falling sand render texture that we're creating. So I'm going to go back into Unity now, and on our image, we need our reference to our compute shader. So I'm going to go ahead and drag that in here. And then we also will need a material for our image UI element. Inside of our shaders folder, I will go ahead and right click and do create shader graph URP unlit shader, because I just want it to be flat lighting. I'm going to call it falling sand shader graph. Double click that to open it. And I know we want a texture 2D called main text. And when I select it, the reference value needs to be this underscore main text value, because in our script we are setting the texture here with this reference. So just need to make sure that is the same. Then I will pull this texture out, feed it into a sample 2D texture node, and then I will feed this into my base color node of the fragment shader section of this shader graph. I will save it, right click on my shader graph, do create material. It'll create our falling sand material. And then this can be set to our image. And I believe our image here is a little too small, so I'm going to update the width to 1920 by 1080, just for like a common HD screen resolution size. Then I'm going to go to my canvas here, and I want to zero out the position, and I want to change the width to 1920 and the height to 1080. And then you should see our white image here. And if I hit play, I believe this should turn black because of our initialize function. So let's try that. And yeah, it turned black. So if I go to my image, I can click on the material, expand this, and it looks like our render texture here got set to the main text here. So that's good. It means our initialize is working and that our image is in full view. So that's great. I think we can also get rid of this global light 2D because I don't think we're using it. Then I want to scale up my main camera's orthographic size until it fits the image perfectly. So I'm just going to keep zooming out, and now you can see how it like will fit. So if I just go ahead and match this up I think 530 ought to do it. There's probably a more mathematically correct way of setting that, but that's just what I've done and it works out fine. So let's move on to actually drawing on the image, as well as the rules for the sand falling. So first, let's focus on the rules for the sand falling. First thing I'm going to do is I want to create a new function for the sand falling. So I'll do # pragma kernel, and I'll call it sandfall. Then I'm going to copy paste this part, add an end bracket, rename initialize to sandfall. And for my range, I'm going to need to know the distance of pixels from where I'm clicking. So to do that, I'll need to have a specific position for where I draw. So I'm going to create a reference float up here for position X, float for position Y, a float for range. And we don't want to be drawing sand all the time. Like if we're not clicking, we won't want to draw sand. So since I'm going to be calling this function every frame and we want to tell it when to draw sand or not, let's create a reference for a Boolean called spawn sand. I will also add a float for color, because it might be fun to have the sand change color over time. And then I also need to add a Boolean for right first. And the reason I'm doing this is because I want to alternate the bias between whether or not a grain of sand rolls down the hill to the right or the left first, depending on what space is occupied or unoccupied. And that way we just won't have like lopsided sand hills. So with these extra parameters defined, I will go ahead and start adding our sandfall function. So I will say float distance equals the square root of id.x minus position x times id.x minus position x. You see, I don't need. And then plus id.y minus position y times id.y minus position y. And id.x and id.y are just the current x and y positions that are passed for the specific spots in the image, and then position x and position y are positions that will pass to the function telling it exactly where we are, and then based on this distance it will be able to tell whether or not a pixel should be filled in while we're drawing based on the range value. So if distance is less than our range and we want to spawn sand, then sand rt at the id.xy position will equal our color that we want to pick. Now I'm going to add the logic for the sand falling. So if sand rt of the id.xy.x, so checking the red value at this position in the image, if it is less than or equal to 0, and I will repeat that for the x, y, and z values, so that's going to be the red, green, blue values, then we are just going to want to return. So to start off with, we will want to have a filled cell at the point that we're focusing on. So if the cell is not filled, then we're just going to return and not do anything. So this could be one that falls outside of the range and was not set to a color, or it could be one that was previously set and then the sand fell and now it's no longer set and it's set to black. Either way, if our current position is not an occupied cell, then we're just going to want to return the function. Also, we need to add if id.y is less than or equal to 0, then also return. Otherwise, the sand will just fall right off of the image. So doing this just kind of adds a floor level where the sand will no longer fall further down. We could do this also with the left and right sides to add walls there, but I don't think it's 100% necessary. Could be a good exercise for you to do if you want. The first position we're going to check is directly below our occupied cell. So if the cell below us is unoccupied, then we'll want the sand to fall directly down. So if sand rt id dot xy plus u int 2, then in parentheses 0 comma -1. So we are going -1 unit down in the y direction. If that dot x, so the red value, is less than or equal to 0, and the other positions, the other values, so I'm going to copy paste a little bit here, but I want to check the y value and the z value. So red, green, blue, if all of those are less than or equal to 0, then what I want to do is set the current sand RT position to black. So I'm going to do float 4 and 0 comma 0 comma 0 comma 0. And then we want to set the position right below equal to the current color value. So id dot xy plus uint go. So plus uint 2 0 -1, and we'll just want to set that equal to color and return. I'll just add a little comment here so we know. Add some more comments up here. Adds a floor to image. Cell is unoccupied. Turn. All right, and then next we will assume that the cell below, directly below our currently occupied cell, is occupied. Then we'll want to check to the left and to the right to make sure that if one of those is unoccupied, then it should move diagonally downward. So I'm going to use our define Boolean for right first because we want to alternate which one we're checking first. Otherwise, we'll have lopsided hills for our sand. So if right first, and then down here is going to be else. And inside of our other script, we'll alternate right and left for checking first. So here I'm going to do if sand rt of id dot xy plus uint 2 and -1 comma -1. Actually, I think it's +1 -1 for the right side, but it doesn't matter as long as we alternate. So less than or equal to 0, and then we'll check our other values. So y, that's z. So again, red, green, blue. If that spot is unoccupied, then we're going to want to do what we did before here. So I'll copy paste this and just make sure this value is copy pasted correctly. So paste over that. And if that doesn't work, then we will check the opposite side. So down here, we're just going to add negative sign in front of all of these ones. So that it should check the right side first, then the left. And if either of them are unoccupied, then it will move the grain of sand down in that direction. And then we'll just want to do the same thing down here, but flip the order. So take that, put that there, this, put it over here, and I'll save. And that should basically be all of our compute shader code. So we have all of the logic in now. And the next thing we'll want to do is go over to our falling sand controller.cs script, and we're going to have to add references to the kernels and the properties that we added. So let's add another private string, and I'll call it falling sand kernel. And I want to make sure it's the same exact name. So I'm going to go over here. I'm going to copy paste the name of the function into here. Then in properties, I'll want to do the same thing. So private string posx property equals, and there's going to be a few more that I want to do. So just to save myself some time, I can show you guys this trick. If you want to add multiple lines in Visual Studio, you can do Control Alt and click on the multiple lines that you want to add. Sometimes it's a little finicky, but here we go. So I don't remember exactly how many I need, but if I do private string pos y property equals double quotes semicolon, now I just have to change this part. So I'm going to want the range property, the right first Boolean property. I'll want the color property and the spawn sand property. And then I think I have an extra line here. Then I'll just want to copy paste the names of the properties exactly. So I'll just go to my compute shader and do that. Copy that. Spawn sand property. Just make sure you're putting them into the right places. Otherwise things might get weird. Right first. Go. Save that. And now I'm going to go ahead and create a fixed update loop. And I'm going to use fixed update because it has a fixed frame rate. I believe it's 60 frames per second. And if you just do the regular update method, then the performance will change with how high of a refresh rate the monitor is, and then also how fast they can run your game. So I'm just going to use fixed update for consistency, but you can definitely just use regular update if you want to play around with that. So we need to be able to send our mouse position. So I am going to create a public vector2 int position, and I'm doing int because we want it to be an integer value because the pixel positions are integer values within the texture. We'll need a Boolean that we'll want to toggle for right first, and I'll just set that to false initially, as well as a Boolean to spawn sand, and I'll set that to first or to false as well. And we'll want a color. I'll just say color there, and I'm just gonna create some float offsets for the color. So I'll do offset R, let's do 0.001, and I'll just copy this whole line here for the other two. So G and B, and I'll just offset them like that. Now in fixed update, we'll need the position. So I'm going to say position equals new vector to int, and I want to get the position of the mouse on the screen. So I'm going to do input dot mouse position dot x comma integer position of input dot mouse position dot y. And to let the simulation kind of run a little faster, I like to add a for loop here that runs a few more times within the frame. So it could run like 4 or 5 or however many times you want, just to make the simulation run a little faster. So I'm just going to do 3 times per frame running the simulation. So instead of the pixels moving 1 pixel per frame, they'll move 3 pixels per frame. And I'm going to want to dispatch the falling sand kernel. And then afterwards, I'm going to want to toggle the right first Boolean, so then we don't have a bias as to which side our sand falls on. So I'll set right first equal to not right first, so then it just kind of flip-flops each time we run it. I'll want to update our colors as we go. So color.r plus equals offset.r or underscore r. Copy paste that for the other values. G, B, B, B. Then if color.r is greater than or equal to 1, I'm going to want the color to ramp back down. So I will say offset underscore r times equals -1. And I'm just going to copy paste that for the other two. So G, G, B, B. And then we'll need it to go the other way as well. So we can copy paste this one more time. And if they are less than or equal to 0, we'll want to do the same exact thing and have them go the other way. And now I just need to be able to tell when I'm clicking the mouse to spawn the sand. So let's do if input dot get key down key code dot mouse 0 for left mouse button. Then I will set spawn sand equal to true. Otherwise, so else if while we have the button down, we want to spawn sand. So else if input dot get key up key code dot mouse 0. So if we detect the mouse button's release, then we want to set this to false. And I also like to add a controller for the range of the sand that we're spawning. So with this scroll wheel, if I scroll up, then I like to increase the range, and if I scroll down, then I'll decrease the range. So I do mouse.current.scroll.readValue.y greater than 0 range ++, and I'll copy paste this if statement again, and I'll just flip it. So if it's less than or equal or less than 0, then this will be -. And our fixed update function should be good here. All we got to do now is update our dispatch function. So in our dispatch function, we're not setting all of the properties we need to. So to do that, I'll just go down here and I will do falling sand shader dot set float, and it is going to be our position X property. And I want to set that to position dot X. We can copy paste this for position.y, change those values to y. Then I want to set it for the range property. So I'll just copy paste it here and add the range property reference there and the range value there. Then we'll want to set our booleans. So let's do falling sand shader dot set bool. And I'll set the right first property to right first. I'll just copy paste this line for our other boolean, which is the spawn sand property. And I'll set spawn sand here. And then the last one we want is our color value. So I'll do falling sand shader dot set vector. And I'll want to reference our color property and set it to our color value. I'll save this, and that should be all we need, I think. So let's go back into Unity, and let's see. Falling sand controller, we have a reference for our sand compute shader range. Okay, now I'm just going to hit play, and do I have... Okay, so one issue we have here, it is telling us down here that you are trying to read input using the Unity engine input class, but you're using active input handling to input system packages, blah, blah, blah. So it's saying we're using the wrong input system. So I'm going to go over to my project settings player, and I think it's under other settings, and active input handling. It's set to the new package. I'm just going to set it to both and apply that. And it's going to need to reboot Unity to apply that. So Unity rebooted. Just so you know, setting both inputs here can be an issue for, I believe, Android builds. I didn't have any issue with it when I deployed to Android when testing this project, but just thought I'd throw it out there. Also, I don't need this tile palette menu. So now I'm just going to go ahead and double check our image. We have our falling sand controller script. I'm going to go ahead and run. Let's see, compute shader kernel index is invalid. So something's wrong with our compute shader. So let's go ahead and take a look at that. We know our initialize one worked. So I found the issue. It's with this square root function here. So if I highlight the parentheses, I can see that for some reason it's only going here. So I'll just delete this extra parenthesis there. And now if I highlight my last parenthesis, I can see the whole thing's encompassed. So go ahead and save that, and then let's go back to Unity and make sure that works. Clear my console. and I'll hit play. Now if I click and drag, I should see something. Let's see. I am not seeing anything. I'm going to set my color to be public just so I can see what color should be drawn. So color is here. I just want to make sure it is being updated. Looks like it might not be. Okay, when I manually set my color, then it draws. And as you can see, the sand is falling down. My input is not replying as well. So I'm going to make a couple changes here. So I'm just going to go ahead and do an update loop. And I believe the input for my mouse to spawn sand, as well as probably scrolling to increase the range, that will need to go into the main update loop here, just because it gets called more often. So then if I'm like releasing the mouse between frames, it doesn't get missed, or if I scroll between frames, then it doesn't get missed. I'm going to do that. And then let's see, my color is not getting. With those changes, I'm going to go back into Unity. I'll hit play, and I still need to fix my color issue, but it looks like the sand is drawing. I'm trying to, I can increase the range of my sand, which is nice. So let me see if I can fix the color issue where it's not changing, because I think that'd be fun. Wait a second. I want this to be 0. Okay. Yeah, that was the issue. These were all set to 1 and not 0. So I bet now it'll work. There we go. Now I have my colors drawing, and they're going to be changing over time. It is flickering a little bit. So if you want to, you can take all the stuff that's in this fixed update loop and throw it into the update loop. It'll just run differently on different machines. I'm going to do it just because I like how it looks. So if you like this video, leave a like down below, leave a comment with any questions. Sometimes I look at those, and I hope this video helped you. Yeah, have a good day. Bye.